Hi everybody, in this video we're going to talk about the quadratic formula. In the previous video we talked about how to solve quadratic equations, and we really briefly just talked about how one method is using factoring, another method is going to be using the square root property. You can also use completing the square, but we didn't even mention, like I didn't even show you how to do one, completing the square. But if you remember how to use completing the square, you can use that method too. But right now we're going to focus on quadratic formula. So we're going to use this method when factoring would either take far too long. So if it takes too long, or if you are unable to factor. So taking far too long would mean like you have 321 for your coefficient of your x squared term, and then you have like 515 for your constant term, because you're going to have to multiply those two together and find the combinations of all of those factors that would add or subtract to combine to give you that middle term. So that's an example where it would take you far too long. There's also times where you just have a prime polynomial in which you can't factor it. So this would be another example when you would use the quadratic formula. This method can only be used for quadratic equations that are in the standard form. So don't forget that standard form is going to be ax squared plus bx plus c equals 0. So we're going to put it in the standard form because as you see below, you've got a, b, and c in your formula down here. And you need to make sure that you're putting it in standard form so you're plugging in the right number. If given a quadratic equation in non-standard form, you will need to put it in standard form prior to solving it using the quadratic equation. So here are your steps. Put the equation in standard form, which is going to be ax squared plus bx plus c equals 0. We're going to identify a, b, and c. And then the third part is we're going to substitute those values into the quadratic formula. And solve. So we're solving for x. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a is what we're going to be using. So for our first example, we have 3x plus 2x squared plus 4 equals 5. And then you should go right back up to step A. And step A says to put the equation in standard form, which means solve for 0. Get 0 on the right-hand side, and then put the rest of them in alpha descending order. So that means I'm going to move this 5 over. And then I'm going to flip these two terms around. So then I'm going to have 2x squared plus 3x minus 1 equals 0. So now I'm identifying what's my a, what's my b, what's my c. So a is going to be the coefficient of your x squared term. B is the coefficient of your x term or your linear term. And c is your constant term. So here we've got a equals 2, b equals 3, c equals negative 1. And now we're plugging it into our formula. So negative b, there's a song that goes to this. Sorry, I was thinking about the song instead of writing the 3 here. But there's a song that goes to this, and it goes to the tune of, well, you can do it to 2 tunes, and you can Google search it. But it's To Pop Goes the Weasel, and then there's another one that's to a One Direction song. And you should Google search them because I would typically show them to you. And then we'd make fun of the weasel because he actually looks like he's panting after he gets done singing, and well, somebody sings and then he's jumping through the video. It's kind of weird, but it's also entertaining. All right, so negative b, which is negative 3, plus or minus the square root of b squared, which is going to be 3 squared minus 4 times our a times our c, which is going to be all over 2a. Common error, you're not going to write a, you're actually going to write 2. Common error that I see on students' work is that you forget to make this fraction bar super long. It should go underneath that entire numerator. So make sure you do that. So now we're ready to do some simplifying. And what I would suggest is that you start with the radicand first. So the radicand, again, is this portion underneath the radical. And so let's work on that. So I'm going to have -3 plus or minus the square root of, and here it's going to be 9. And then this is what I'd like you to do. I want you to go count your negative signs so that we know whether to put a plus or minus here next. And because we've got 2, our sign here is going to be positive because a negative times a negative is going to give us a positive. And then 4 times 2 times 1 is going to give us 8. And then that's going to be all over 4. So then keep going. We've got -3, and double check your fraction bar. Is your fraction bar underneath the entire numerator? So then we've got -3 plus or minus the square root of 17 all over 4. So then you stop and you think, okay, can I simplify the square root of 17? Is that something I can break down any further? And you can't. There's nothing more you can do with that. So another way you could rewrite your answer, and Ed Ready will show it to you like how I'm getting ready to show it to you, so you might want to write it down so you have it, is going to be -3/4. So it's going to be -3/4 plus or minus the square root of 17 all over 4. So they're just splitting it up. This goes over the 4, this goes over the 4. They might even go one step further, because if we were, again, graphing this, fast forward a few more days, when we graph this, you would have to put it all into decimal form. And so one of our answers would be -3/4 plus the square root of 17 over 4, or it would be -3/4 minus the square root of 17 over 4. And we would figure out what each of those are as a decimal, and then we would graph those, because that would be, this would be one x-intercept, this would be our second x-intercept for our graph. So we're going to try another one. So the next one I would like for you to try, I'm going to try to squeeze it in up here. We're going to have x squared plus 6x minus 5 equals 2x. So first step, again, go ahead and put that into standard form. So if I was you, I'd just start working on it, and then maybe you can beat me through the process. So we're going to subtract the 2x, and then we're going to have x squared plus 4x minus 5. That equals 0. This one happens to be factorable if you're a factoring person. This one's going to be this one, when I said this one, I mean 1. 1 is going to be A, B is going to be 4, and C is going to be -5. So yes, I want that step in there. Some students ask me, do I have to write that in there? Yes, write it in there. So then we're going to do -4 plus or minus the square root of 4 squared minus 4 times A times C all over 2 times A. So again, I'm going to simplify what's underneath the radical, and I've got -4 plus or minus. I've got 16 plus 20, because minus a negative is going to give me a positive, and then 4 times 1 times 5 is 20. That's going to be all over 2. Then my next step is going to be -4 plus or minus the square root of 36 all over 2. And then I'm going to keep going. I've got -4 plus or minus 6 all over 2, and keep going. One of our answers is going to follow this positive route. And so it's going to be -4 plus 6 all over 2. -4 plus 6 is going to give me 2. And 2 over 2 gives me 1. So that's one of my answers. My other answer is going to be following this negative route here, and it's going to be -4 minus 6 all over 2. which is going to give me negative 10 over 2, which gives me negative 5. So my two answers, I would have 1 and negative 5. And again, if I was graphing that, that would be 1, 0 and negative 5, 0. So again, that's coming. We just haven't done that yet. So we're going to do some more. So number 3 is going to be x squared minus 6x equals 2x minus 16. So again, put that in standard form. So I'm going to bring the 2x over, add the 16 over. So then these are going away. And now I've got x squared minus, I almost wrote minus 2x, minus 8x plus 16 equals 0. This one's also factorable if you're a factoring wizard. A equals 1, B equals negative 8, C equals 16. So we're going to plug that into our formula. Negative B, so here's another question I get. So if the B is already negative, do I have to make it negative? Well, yeah, I mean, but you're putting negative B, and B happens to be negative. And so then it's going to be minus a negative, which is going to give us a positive. So we've got negative negative 8 plus or minus the square root of negative 8 quantity squared minus 4 times my A times my C all over 2A. So my negative negative is going to give me a positive, so it's 8 plus or minus. Here we've got 64. It's going to be positive because it's a negative 8 times a negative 8. Now do your 4 times your 1 times your 16. 16 times 2 is 32 times, and like take that twice because that'd be 16 times 4. I was going to give you 64. So you've got that all over 2. Well, what happens underneath the radical? Underneath the radical is going to give us 0. So now we've got 8 plus or minus the square root of 0 all over 2. What's the square root of 0? 0. So 8 plus or minus 0 all over 2. 8 plus 0 is 8. 8 minus 0 is 8. So we get 8 over 2, and we get 4. Why didn't we get 2 answers? Because underneath the radical was 0. If you add 0 and subtract 0, you're going to get back the same number. And so for this one, think about that. For graphing, how could it work out that we would only have one x-intercept? Like, how could our parabola look like that? So remember, a parabola looks like this, right? How could we only have one intercept? And it would be because it's at the vertex. So when we only get one answer here, one solution, that means that the point that intercepted the x-axis is going to be the vertex of our parabola, whether it opens up or whether it opens down. All right, let's try another one. So number 4, we've got x squared plus 2x plus 5 equals 0. This one happens to already be in standard form. So A equals 1, B equals 2, C equals 5. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So we've got negative 2 plus or minus the square root of 4 minus 20 all over 2. And then we've got negative 2 plus or minus the square root of negative 16 all over 2. And then go back to what we were talking about in that previous lesson on roots and what happens if we have a negative underneath the radical. It means we're going to pull out an I. And we also think about, well, what does it mean to have the square root of 16? And it should be 4. So on this one, we're now going to have negative 2 plus or minus 4i all over 2. And then we can keep going. We can keep reducing this. It's going to be negative 2 over 2 plus or minus 4i over 2. And now we reduce. Negative 2 over 2 is negative 1. 4 over 2 is going to give us 2. So it's going to be -1 plus or minus 2I for our answer. So that means I've had some people say, well, how would I graph that? Because one of my answers would actually be -1 plus 2I and -1 minus 2I. So how would we graph that? Well, we can't, not in our two-dimensional plane that we would do on an XY grid. And so how could that happen? Like, you should think about, like, how is it possible? Because what that means is that I don't have any x-intercepts. That's what that means. So we have no x-intercepts is what that means. And so you need to think about that. Like, what does that mean for our parabola if we don't have any x-intercepts? And what that means is if we have our grid, that means our parabola has moved up like this, so it never crosses the x-axis. Same thing here, or it could be like this. So that just means it's never ever crossing our x-axis here, which is why we get an I in our answer, because we don't have any x-intercepts. All right. What is this, number 5? All right, so this one we're going to have 2 times the quantity of x plus 3 squared minus 5x equals 6. And this one, it's going to take us a little bit to get it into standard form. So what I would like for you to do first is maybe pause the video and think about how are you going to get this into standard form. So looking at that, and please don't tell me that you're going to distribute the 2, this 2 in, and don't tell me that you're going to distribute this 2 in, because both of those would be incorrect. All right, here we go. So we're going to do 2 times x plus 3 times x plus 3 minus 5x, and I'm going to go ahead and bring my 6 over because I know I'm going to need to eventually anyway. I guess I'll just distribute it here first. All right, so our first one is going to be 2x plus 6. And then we're going to do x plus 3. And we're going to have minus 5x minus 6 equals 0. And now we're going to FOIL. So we're going to go here, first terms, outside terms, inside terms, last terms. So 2x times x is going to give me 2x squared. 2x times 3 is going to give me 6x plus another 6x plus 18 minus 5x minus 6 equals 0. So let's combine our x's in here. And we're going to combine our constant terms too. And so we should have 2x squared, 6 and 6 is 12. 12 minus 5 is going to give us 7. And then 18 minus 6 is going to give us 12. And that's going to equal 0. Let me make sure I'm on the right path. I am. And so at this point, we've got it in standard form. Now we're going to identify our A, B, and C. A equals 2, B equals 7, C equals 12. I'm definitely going to run out of space, but I'll move over to the right when I do. All right, so -7 plus or minus the square root of 7 squared minus 4 times 2 times 12 all over 2a. All right, I'm going to move over here. So then we've got -7 plus or minus. We've got 49. What does the other number end up being? We've got 8 times 12. Okay, that's 96. Minus 96. And then we're putting that over 4. And then what does that end up being? -47. So if I think about 96 minus 50, be 46, 47. Okay, so -47. So -7 plus or minus the square root of -47 all over 4. Get rid of this. Oops, I want to get rid of that. And so I'm looking at my final answer, and I don't see anything that we're going to be able to simplify with the -47, but I do see something we can take out. I didn't mean to erase that. We have a negative right here And we can pull that out. So we could say negative 7 plus or minus I root 47 all over 4. And then we can split it up, right? So we can write negative 7/4 plus or minus I rad 47 all over 4. So yet again, that means that we do not have any x-intercepts for our graph on that one. Okay, we're gonna look at the next part. The discriminant. I love that word, the discriminant. How many solutions and what type? All right, well, we're gonna take some notes and then we'll talk about what the heck is the discriminant. So this is where it's helpful. What if we only wanted to determine the type of solutions, meaning real or complex? Complex means they have i's in them. Real just means the real number system. So they're all part of the real number system. The complex means the complex number system. So we're talking about the complex number system, and that's when we have i's in our answer. And so what if we wanted to determine the type of solution and then how many of each type? So would it be 1 or 2? And really our choices are going to end up being 2 real solutions, 1 real solution when we get the when we get a 0 underneath our radical, right? That's when we came up with that 1 real solution because our vertex was on the x-intercept. That was on the previous page, and then the 2 complex. So those are going to really be our 3 options that we're going to have. And then I'll talk about those 3 options down here. So is there a quicker way to find the answers to the questions above without actually having to do the full and complete quadratic equation? And the answer to that is yes. So here's where the discriminant is helpful. So if we're only asked to find how many solutions does this quadratic equation have, and what type, all we have to do is calculate the discriminant. So it speeds up our process quite a bit. So yes, calculate the discriminant. All right. So the definition, the discriminant, we got to spell it again. Discriminant is the expression under the radical or under the root. It's going to be the b squared minus 4ac. So computing the discriminant provides useful information regarding what type and also how many solutions a quadratic equation has. So I was giving you all that information on the previous examples about how many x-intercepts we would have, whether we would have 2 x-intercepts, 1 x-intercept, or no x-intercepts, because it's going to come in handy right here. So if what we got underneath the radical, so think about this, because the b squared minus 4ac lives underneath the radical, right? So when we got a positive number like 16, we ended up getting 2 answers. We got 4 and negative 4. So what that means is that if b squared minus 4ac is greater than 0, so that means it's positive, right? So if it's positive, then the equation is going to have 2 real solutions. And real, again, not meaning real versus fake. We're talking about 2 real, like we can actually graph them on our 2-dimensional plane, and they're part of the real number system. So we're going to have 2 real. The other one is what happens when what's underneath the radical equals 0. Remember that example? That example was back here, right here. So what happened when it equaled 0? Well, we ended up, how many solutions did we get? We got 1 real solution. So we get 1 real solution. And then what happens when what's underneath the radical is less than 0, which means it's negative, right? So that means we're getting like negative square root, or square root of a negative 16. And this one would equal plus or minus 4i. And so we would get two solutions, but are they real or are they complex? They're complex. They're part of the complex number system. So they'd be two complex solutions. So for this one, let's say that we had this problem and I gave you x squared minus 4x plus 10. And all I want you to do is tell me how many solutions are you going to get and what type. So how many solutions are you going to get and what type? So what we're going to do is we're going to calculate the discriminant. We're going to do just this part. So we're going to do 4 squared or negative 4 squared minus 4 times our a, which is going to be 1, times our c, which is 10. And then we're going to get 16 minus 40. And I'm going to tell you right now that already means we're getting a negative underneath the radical. What does it mean when we get a negative underneath the radical? How many solutions and what type? We're getting two complex solutions, right? So we're getting two complex solutions for that. And if you wanted to finish that out, you could say, well, that's going to be the square root of negative 24, which also gets you to that point. All right, so if we tried another one, let's say we had x squared minus 3x equals 7x minus 25. That's a 25. So x squared minus 3x equals 7x minus 25. So bring your 7x over, bring your 25 over. So we're going to have x squared minus 10x plus 25 equals 0. Doing your discriminant again, negative b, or not negative b, it's going to be b squared. What am I doing? B squared minus 4 times our a times our c. So here we're getting 100 minus 100, which is going to give us the square root of 0. And the square root of 0, how many and what type? Is going to be one real solution. And then our last one, guess what? What's this one going to be? 2x squared plus 5x minus 6 equals 0. So b squared is going to be 5 squared minus 4 times 2 times negative 6. And we're going to have 25. This is going to be plus, and then we've got 24 times 2, which is going to give us 48. And you can already tell it's going to be positive, right? So we've got 25 and 48, 73. All right, so the square root of 73 on that one, so that means it's positive underneath the radical, and then we're going to get two real solutions on that one. And let me see what's next. So what we've got on the next page are our application problems. And on these application problems, I have to say that I think sometimes the hardest part on them is just, one, maybe setting them up, and two, plugging them into your calculator to make sure you're getting the right answer. So I very much encourage you to get your calculator out and make sure you're following along and that you're also getting the same exact numbers that I'm getting as we're working through this. So I'm going to grab out my calculator too, in case I don't have some of the steps written down for me. So what we've got here, it says a ball is thrown off a building from 200 feet above the ground. Its starting velocity is negative 10 feet per second. The negative just means it's heading towards the ground. The equation that we're given can be used to model the height of the ball after so many seconds. So this ball is going to be thrown off. We're given our height formula. So it could be like, how high is the ball after 1 second, after 3 seconds? And so we would expect that as time is increasing, our ball is getting further and further towards the ground. So this is our height, and our height over here is 200 feet when we start, and then it hits the ground. Okay, so it says about how long does it take for the ball to hit the ground? So we have two variables in this equation, and we need to figure out which one we're solving for. So this one says about how long. So that one tells me that we're solving for time because we're looking for how long. Well, then what are we going to plug in for our height? What is our height at the ground? Right here. And our height at the ground is 0. So we're going to plug in 0. for our height for this part right here. And so I'm going to go ahead and just write it as negative 16t squared minus 10t plus 200 equals 0. And then A equals negative 16, B equals negative 10, and C equals 200. And now we're going to plug that into our quadratic formula. So we've got negative b, or negative 10, plus or minus the square root of b squared minus 4 times our a times our c all over 2a. All right, so I'm going to simplify some things. That negative is going to give me a positive 10. And then here I'm going to get negative 10 squared is going to give me 100. My next sign is going to be positive because I've got negative. And then I've got 4 times 16 times 200, and that should give me 12,800. Check it. Make sure you're getting the same thing. All over negative 32. Now we're going to do 10 plus or minus the square root of 12,900 all over negative 32. And then you should check. I don't remember if it's not. So I was about to say I don't remember if it's a perfect square or not, but it's not. So what I would encourage you to do, it's really good to not round early in this part of the calculation. Like you don't want to round this right now because then your answer at the end is going to be off. So here's what I would encourage you to do. We have two different answers that we're going to use. We've got the positive version of the square root of 12,900 and the negative version. What's the sign on our 10 right now? The sign on our 10 out front is positive, right? Because it doesn't say negative. So here's one way I would like you to try this. Take the positive version of 12,000, the square root of 12,900, and we're going to go like this. 12,900, here's the positive version, plus 10, and that's going to be all over negative 32. So you plug that into your calculator, and then the other version, the negative version, is going to be negative square root of 12,900 plus 10 at the end, all over negative 32. So you plug those both into your calculator, and what you should be getting, what is that one? So for the positive version, what you should be getting is negative 3.86 seconds, and I'm going to put an approximation sign here because that does not exact. Approximately negative 3.86 seconds. Think about that. Negative 3.86 seconds. So that's like going backwards in time. That doesn't make sense. So that's the one we're going to cross off, and I hope we do something better in the next one where we get a more reasonable answer. And we should, because we've got a negative over a negative, which is going to give us a positive. So then the next answer that we should be getting is approximately 3.24 seconds for this next one, which should be our answer. So definitely pause the video. See if you can get that on your own in your own calculator, because you definitely want to make sure you know how to do these problems. So you're going to see them again. All right, so number 2, we've got a baseball 4 feet off the ground. It's hit with an upward velocity of 52 feet per second. The height of the baseball in feet after t seconds is given by the following equation. A fan catches the ball 16 feet off the ground when it's coming down. When does the fan catch the ball? Note, the ball is 16 feet high at one point when it's going up, and then when it's coming back down. So like think about the fact that we've got like a baseball player, right? Here's his bat. We're hitting the ball. It comes up, it comes back down when the fan's catching the ball. So it's going to hit, so right here it's at 4 feet, and then here it's going to be 16 feet, and then over here it's going to be 16 feet again, right? Because if it's like down here 0, and then you're hitting it, and this is 4, and then this is definitely not drawn to scale, and then as it's going up, it's going to be at 16 feet, and then back down as the fan catches it, it's going to be at 16 feet again. So we are needing to plug this back in. Again, it says when does the fan catch the ball? And And so we're looking for time. So at what time is it at 16 feet? So we're gonna get two different answers. We're gonna have to throw one out. So we're gonna set this up as negative 16t squared. We're looking for t plus 52t plus 4. On the last problem, we set it equal to 0. What should we be setting it equal to this time? Because it's not 0. What's the height of the ball? 16 feet. That's what we're looking for, right? So that's what the variable is, or the number we're plugging in for that variable. So we're going to bring that 16 over. And we're going to have negative 16t squared plus 52t minus our 12 equals 0. And so we're going to set up all of our variables here. So a equals negative 16, b equals 52, c equals negative 12. And we're going to plug that in of negative 52 plus or minus the square root of 52 squared minus 4 times negative 16 times negative 12 all over 2a, 2 times negative 16. So here we go. We're going to do negative 52 plus or minus 52 squared. I don't think I wrote that one down. I'm going to put that in my calculator. We should be getting 2,704. So about 2,700 is what I was about to say. And then look at your next sign. We've got 3 negatives. So we should be writing a negative here. And then 16 times 4 times 12 should give us, it looks like 768. I'm just going to do that again, make sure I didn't punch anything in wrong. 768, and then that's going to be all over negative 32. All right, so while I've got that 768 still on my calculator, I'm going to make it negative, and then I'm going to add 2,704 to it. So what's underneath the radical should be 1,936. Now you should be taking the square root of 1,936, and it happens to be a perfect square number, which is great. So then we're going to have plus or minus 44 all over negative 32. All right, I'm going to move to the top over here. So one of my answers is going to be negative 52 plus 44 all over negative 32. And I'm just going to punch that into my calculator. So plus 44, which should give us negative 8, and negative 8, which we could do this part, divided by our negative 32. So we've got negative 8 over negative 32 is going to give us a quarter, right? So if we divided that, it'd be positive 1/4. But what that means is it's 0.25 seconds. So you think our fan caught it at 1/4 of a second? I highly doubt it. I have a feeling our 1/4 of a second is this one. All right, let's check the next one. So our next one is going to be negative 52 minus 44 all over negative 32. And so we've got negative 96 all over negative 32. And then you can ask yourself, well, how many times is that going to go into 96 evenly? And I hope you say 3. So it's going to be 3 seconds. So which one of these are we throwing out and which one are we keeping? Can't be that one. It makes far more sense that it's going to be 3 seconds. And so that's the answer to that one. All right, I think we've got a couple more word problems. We do. Let's look at these two. So it says, a baker knows that if he charges X dollars for a cake, he will sell 20 minus X of those cakes each week. So I want to point something out. So this is going to be the cost of each cake, is what this is telling us. This is the number of cakes that we're going to be selling. Number of cakes sold per week. Thus, the total revenue, so how much money we're bringing in for the cakes in dollars, can be expressed by the following equation. And we're supposed to come up with that. So how do we come up with how much money that we're bringing in? Well, it's going to be the cost of each cake times the number that we sell, right? So the cost of each cake times the number that we sell is going to be revenue equals the cost of each cake times the amount that we sell, right? That makes sense. Like if you sell 10 cups of juice or something, and each cup of juice is so much amount of money, then you're going to multiply those two together to find out how much total money you bring in. So here's our equation, and you're going to have to come up with your own equations on Ed Ready too. So that's why we did this one. 1 week, the baker's total revenue for these cakes was $84. How much did he charge for each cake if it was less than $10? Okay, so it gives us two pieces, well, it gives us one piece of information about the revenue. Total revenue is going to be 84 bucks. So that's going to go in here. How much did he charge for each cake? What are we looking for? We're looking for X. We're going to solve for X, and then it also tells us which one we're going to throw out. It has to be less than 10 bucks. So there's going to be one answer that's going to be greater than 10 bucks, and we're going to throw that one out. All right, so we're going to have X times 20 minus X. I'm putting my revenue on the other side, equals 84. So again, quadratic formula, we need to get it into standard form. So we're going to have 20x minus x squared. I'm going to go ahead and bring over my 84 because I'm going to have to do it anyway. Now I'm going to rearrange. I'm going to have negative x squared plus 20x minus 84, and that equals 0. So A equals -1, B equals 20, C equals -84. So we're going to have -20 plus or minus the square root of 20 squared minus 4 times -1 times -84 all over 2 times -1. So now we're going to just do some little arithmetic here. So we're going to have -20 plus or minus 20 squared should give us 400. And then we've got, what's the next one going to be? I don't think I wrote it down. So we're going to do 84 times 4, which is going to be -336. So then, and by the way, it's going to be negative because we have 3 different negatives in there. And that's going to be all over -2. So I'm going to bump to the top of my page over here. And we've got -20 plus or minus, that's going to give us square root of 64 all over -2. And so we're going to have -20 plus or minus 8 all over -2. One of our answers is going to be -20 plus 8 all over -2. And our other answer is going to be -20 minus 8 all over -2. So -20 plus 8 is going to give us -12. -12 divided by -2 is going to give us +6. This one over here is going to give us -28 divided by -2 is going to give us 14. So then you go back. How much did he charge for each cake if it was less than 10 bucks? So it's not going to be this one, and it's going to be $6 per cake. Don't forget your label for that one. Okay, one more. Please don't tune out on this one. I know it's been a longer lesson, but this one can be a little challenging. So let's make sure we've got this one down. A rectangular art canvas that is 40 inches long by 20 inches wide is surrounded by a rectangular frame. So let's draw a picture. So I've got my canvas. It's like this. And then I've got my frame that goes around it. Like that. And it says my canvas is 40 by 20. And the distance from the canvas to the outside of the frame is X. So that means this is X and it's all the way around. So that just means it's symmetrical all the way around. So the distance between the frame and the canvas is going to be X all the way around. And I'm putting these strategically on the corners because of what's coming next. And it says all the way around, okay, the total area enclosed by the frame. So that's taking the entire area. So like this plus this. So the total area of the entire thing, all of it, is going to be 1,500 square inches. So inches squared. And it wants to know what is the value of x. Well, we have a rectangle here and it's giving us the area. So you should ask yourself, what's the formula for the area of a rectangle? And the area of a rectangle is area equals length times width. Well, how can we express the length of this picture and frame in terms of x? So that means we're going to have an x in our expression down here. So how can I express the length of that frame in terms of x? Well, how long is it? We know that this portion over here from up here is x. We know that this portion down here, so like this right here, is 40, and we know that this is x. So how long is that side? It's 40 plus x, or it's 40 plus 2x, right? So that's the length for this bottom piece, because we're taking x plus 40 plus x. Now do the other side. So if we're doing the other side, we're now looking at this length here. So our width, and how, like, we know what this is, this chunk, that's going to be 20, because that's what was given right here. And we know that this piece is x, and we know this piece down here is x. So that means our width over here is going to be 20 plus 2x. Well, now what? Well, now we know that length times our width is going to equal our area. So that's what we're going to write in here. So we're going to do 20 plus 2x times 40 plus 2x, and that equals 1,500. So we're going to go ahead and FOIL. And so the first one up here, let me see here, in our foiling. Okay, so go ahead and we're going to do 20 times 40, and that should give us 800. And then our next one, 20 times 2x, should give us 40x, plus 80x, plus 4x squared. I'm going to go ahead and bring the 1,500 over, because I know I'm going to need to do that anyway. Just making sure I'm on the right path, making sure my numbers are looking good. Okay, so we've got 4x squared, so I'm bringing that to the front. 40x and 80x is going to give me 120x. And then we're doing 800 minus 1,500 is going to give me negative 700 equals 0. And so when we're plugging things in, it's going to be A equals 4, B equals 120, and C equals negative 700. So I'm really going to have to squeeze some things in here, but here we go. I'm going to do negative 120 plus or minus the square root of 120 squared minus 4 times my A times my C all over 2A. And so our 120 squared, I'm gonna try to squeeze it in through here. We'll see how I do. Where it's gonna be negative 120 plus or minus the square root of 14,400 plus, then we've got 16 times 700, which should give us 11,200 all over 8. And then once we're adding up what's underneath the radicand, or what's underneath the radical to get the radicand, we're going to have negative 120 plus or minus the square root of, it looks like 25,600. Yeah, that looks right. All over 8. Now you want to take the square root of 25,600 and see if it comes out. It should come out to a perfect square of, I'm going to come up here now, negative 120 plus or minus 160 over 8. And so one of my answers, so doing negative 120 plus our 60 is going to give us what? So we should have 40 over 8, which is going to give us 5. And the other answer is just going to give us something negative. It's going to be negative what is that, negative 280 over 8, which ends up giving us negative 35 inches, which for a length doesn't make sense. So we end up crossing this one off, and x equals 5 inches. Don't forget your label. So thanks for tuning in. I know that was a longer lesson, but good job hanging in there.